Welcome back again. Today we are going to talk about set operation, the second section in the chapter 2. We have a set operation. Of course, we have two sets. Then we are going to do operation on it. I know you saw that one before in the maybe secondary school. We have a union. Union means that collecting all things and putting in one basket without repetition, without duplicated. So we are going to remove it. For example, and also if we have a, so you can see we have a set like A and B. Any set, we can give any example. If I have set A equal to 1, 2, 3, and if set B equal to 1A, B, C, when I say A union B, I mean by what? A 1, 2, 3, A, B, C, and we are not going to repeat one again. That's called what? Called union. And how about intersection between A and B? I'm going to check or find the common between these two sets that they have it. So I'm going to check A and B, and I'll see only elements that we have is what? A single one. So here's the definition of the AU. You have X, A, or in B, and there's an example. And how about intersection? You can see the set between two sets, the collection or the set or the common element between A and B. Okay, and B. So here's another example. You can see from here 1, 2, 3, 1, 2, 3. So when I say intersection, I can see there's a common between them is 1 and 3. Clear? Good. Now we have two sets. It's called disjoint. Here's a definition. During the exam, maybe I say show them they are disjoint if the intersection between them is equal to phi. So it means that, look at here, this example, A and B. A is the odd, less than 10. B is even from 10 to, or let me see, less or equal to 10. You can see the intersection between two this set is nothing. Means that it's empty set. So in that case, we say A and B, they are disjoint. There is no relation. They are not joined, they are disjoint. And of course, you can use the Venn diagram to show them union of set and also the intersection. Whenever we have two disjoint set, when we say intersection between them, they are phi, means that here's A, here's B. You can see there is no relation or no connection or no joint, not common between these two sets. Clear? So here we are, and here's the definition. Any question about the, what do you say, the disjoint set? No? Now, what's the difference between two sets? We don't have a minus, careful. We have a difference. So we have two sets, A and B. If you like to find the difference between them, you can follow the definition. Say what is here's the definition. The set is equal to X such that X in A but X not in B. And 100% A difference B is not equal to B difference A, because the set, we are talking about the set. Maybe depending on this definition, the result will change. To get more information, here we are. We have, for example, A equal to 1 to 5 and B equal to 1 to, that's it, or let me say 6. So if I want to find A minus B, a difference B, not minus, difference, means that I'm going to check the set A, that the element, I'm going to check A, 1 belong to A. I'm going to ask myself, 1 belong to B or not? Belong, so it's not in the difference. And I'm going to check 2 belong to A. I'm going to say 2 belong to B or not? B belong to B. And 5 belong to A. I'm going to check 5 belong to B or not. So I'm going to put 5 here. Clear, dears? How about B difference A? Can you answer? Equal to? Only 6. You are. Clear, Jamaat? Guys? Good. So here's the difference. Here's the definition between them. You can see here's another example, and check the atom kindly. And this chapter contains many concepts, many names, many things, but all of them, they are easy, but with the detail. So you need a little bit patience, a little bit concentration. So we have a complement. Complement is that the reverse of the other. For example, then of course we have a universal set, and we have a complement, and we have a is like that. What do you mean by complement? For example, if I say my set is equal to a universal set, I have a universal set, is equal to 1, 2, till 10. So I have 10 elements, right? And I'm going to say A equal to 1, 3, 5. Now, when I say a complement, I mean all these elements that they are in the universal set, but they are not belong to A. Is equal to what? Can you reply?
Anything but 1.
Yeah, so 2, 4, 6, 7, 8, 9, 10. So this is the complement. Clear? In my set, universal set, I have only, for example, in universal set, I have 1, 2, 3, 4, 5, 6, okay, and 7, 8, 9, 10. And we say A is what? A is contain 1, 3, 5. So this is A. Of course, the other is a complement. Complement again. Okay? The integral of it, the other part. And we have a such property with the complement of A. You can see A union A complement is equal to what? Universal set, right? Is equal to universal set. And you can see A intersection A complement is equal to what? Nothing. Fine, because they are disjoint. They are complement to each other. Understood? If I ask you, complement of complement A equal to what? To A itself, right? To A itself. So we have many things here. You can see a complement. Here's the definition. All elements does not belong to A. And here's the more example. If I have a vowels, for example, we have A, E, I, O, U. So tell me about the complement of the A. You can see from A, B, C, D till N without these elements, right? Again, we have a complement of, he say what? Let A be the set of positive integer greater than 10. So A, now I define a new set for you. During the exam or quiz, I say if A equal to all those elements X such that X greater than 10. So tell me about a complement. X is what? X belongs to Z positive. When I say Z positive, I mean 1, 2, 3 till infinity. So tell me about a complement is equal to what? So less than or equal to, right? From 1 to till 10. You got it here? Clear? Any question, Kaka? No question? Tamam? Good. It's easy, but need work. You can see from here. And we have a property that sometimes there's a relation between A and A difference to the complementary. What do you mean? I mean by this one. We say A difference B is equal to all these elements that they are belongs to A, but X not belong to B, right? Now, A is not and B is not belong to B. But you can see, you can write A belong to A and X belong to B complement. Am I right? Because if they have a universal, X not belong to B, of course belong to the other part, complementary part. So that's why we can summarize, we can make a decision, make a rule that what? We can say that if A difference B, we can summarize it as A intersection B complement. Why? Because we mean by element here, element not here. So means that and between them. So it means that X belongs to intersection of the A and B complement. We are going to use that one maybe for answering the exercises. So kindly pay attention for that. And here's the A. and A complement and universal set. Do you have any question, dears? No. Now we have rules, we have properties, identities, that all these concepts that I gave you, we have a property with it. We have identities with it. What do you mean? For example, we talk about intersection, right? So usually intersection with a universal set or with the biggest set, you will get the smallest one. And usually union will give you the largest one. What do you mean by that? For example, if A equal to 1, 2, 3, and B is equal to 1, 2, 3, 4, 5. Let me say 5. Which one is, of course, A, we have this condition, careful. A is a subset of B, am I right? Can you check it? Do you agree with that one? So how about B? B is subset of A? No, good. Now, if A is the smallest set with the biggest set, with the largest one, if I say A union the largest one, small largest the union the biggest one, of course you will get what? Largest. If I say biggest one, if I say A intersection with the smallest one, so this is the biggest and this is small, of course you will get smallest, right? So generally speaking, that's why we have here, we have a U intersection union, you will get A union phi is equal to phi, and the intersection between them also you'll get phi. Do you have any comment on the first and the second? How about A union U? Of course. Union with a set that you will get the same without repetition. Of course, intersection itself, you'll get the same set. How about complement of the complement? We say that. Complement of the complement will be what? Yes, the original one, the set, original set. AUB is commutative union. Of course, intersection also commutative. As well, we have associative. If you have three sets with a parenthesis, we can play with them like that because the result will not make a change. You will get the same result. And we have a distribution. What do you mean by distribution? As a and or. You remember that. We say we can distribute between them. So finally, in the exercise, we are going to use that one. Okay, Kaka? We are going to use that one. How about distribution over union? How about distribution over union? You get what? The same, right? We can say A intersect B, union A intersect C. So that one is called intersection, as we have it in what? In the or and. Okay, dears? What was De Morgan? De Morgan, it was about negation of A or B, right? Here we have a union and intersection. So if I have a complementary of A intersection B, if I want to apply De Morgan's law here, if I have A intersection B, I see is equal to A, okay, union B complement. Clear, dears? That's how we answer. And of course, we will get A complement, intersection B complement. If you remember, we changed the and to or to and. Now here we change the union to intersection and vice versa. Do you have any problem? And we talk about that one, and I'm going to leave that one for you. You will get the same. It's called observation law. Any question, dears? Good. طبعا we don't want to prove actually. Forget about the proof. Forget about the example 10. Just we are going to use that one as an identity, not proving. And but that one is we are going to use them. So kindly try to study them. And let me check the examples. And also we don't want to solution, that example number 12. Yes. Later I'm going back to this example. Yes. Later I'm going back to the example 11, okay? So I'm going to example 13 before we finish. Okay. So if you have a such code like that, it's called membership, as atomic or something. You can, if you have a set like that, a equal to 0, 1, 0, like a true, false, true, and we have a 3 sets, right? So we have 2 to the power 3 is equal to 8. So we have a, and also we have what? We have true, false, 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 and true, true, false, false, and true, false, true, false, you know, like that. Now we have 1 and 0, 0. So how about union between them? How we do like that? You can see union between 2, you will get what? You will get 2. An intersection between them, you'll get the same. And just kindly check it. If you have a problem, let me know. So now we have a B union C. Means that 1 or 1. So I'll get what? I'll get 1. 1, 0, because we have a OR, we say 1, and the others is like that. How about A intersection of that one? Means that A with intersecting here. So intersect true, or 1 true. And how about 1 with 1, again 1, and 1 with 1, again 1, and 1 with 0, I'll get 0, and go on for the others. Kindly check all this one at home. Clear? Maybe I'll give you the set like that. I say find the combination them and find this and show me they are equivalent, they are equal. For example, I say use membership table. When I say membership table, you should use that table. Clear, dears? Any question? Any problem? Good. Going back to example 11, yes. So I say use the definition, for example. I say use the definition to show me that one is equivalent to that one. What do you mean by definition? I don't say go to define for me. No, we know the definition of here is equal to what? Generally, we are going back to definition of the, we say a complement. We say a complement is equal to what? All those x's such that x does not belong to A. Am I right? So now I have A intersection B complement. So depending on that one, I say is equal to all those x's such that x does not belong to A intersection B. Instead of one set, I have combination between two sets, right? So here we are. Do you have a problem with it, dears? Clear? Good. Then we say x does not belong to A, and x does not belong to B. Am I right? Because you have an and, does not belong to all of them. Now, take a negation. Take a negation. I say what? I say not belong, or sorry, not or between them. Or you can use another step. You can use another step, taking a negation to out. I say x belongs to A or B. You got it? Then I say those x that does not belong to x or x belongs to B. How? Because I have that property, union, means that between both of them belongs. Okay? Now, part by part, I say x, it was intersection, sorry. Intersection. Now, I can say what? I can say is equal to those x such that x, negation of x belong to A, negation of or, negation of x belongs to B. Right? So which means that x does not belong to A, or x does not belong to B. was equal to, I know you are a little bit confused, but be patient. I'm going to review it for you. X belong to B A complement or X belong to B complement. Then you will get what? You'll get X belong to A complement union B complement. What was going on? Let me check the lecture for you and show you on the lecture. Look at here. We say X does not belong to here. So if I took the negation, I will get what? To out. X does not belong to that one, X belongs to that one, right? So that's why I told you we have X, we need to show that one. We say is equal to all these elements such that what? Such that X does not belong to A intersection B. How? How I change that one? Can you tell me? Yalla. Yalla, good morning. How I say that one? By which definition? No. No. Yalla. Kaka. Look at here. Give me the definition of A complement. We say what? We say all these elements such that X does not belong to A. Am I right? Now give me that one. The same. I say X. X does not belong to the set. Am I right? So depending on the definition of complementary, right? When I say complementary, when I say this student is not here, so it means that he's belong to the other part. Clear? You are not belong to this section, so it means what? You are belong to the other section. Clear? Good. Now, if I took the complements, I say I want to change that onto the positive part. So I say X belongs to, am I right? X does not belong, X belong. Okay. Now, ama box a small box. Now I say elements. Hazaki, forget about that one. Later I'm going to make it, okay? So I can imagine to taking out the negation part. Okay. So tell me about the box. Box means that X belongs to A. What's the definition of intersection? Between is belong to that one and that one. So I am the teacher of the discrete. So I'm teaching section 1 and, not or, and section 2, right? So X belongs to the A and B. So and X belongs to B. Am I right? Now, distribute, now is the De Morgan's, Kaka. Now is De Morgan's time. Distribute the negation. I will get X does not belong to A or X does not belong to B. I use the De Morgan's rule. So tell me is what? Means that X does not belong to A union B. I am not teaching Cal 1. So I'm not teaching Cal 1, section 1 and section 2. So we get what? We get union. So, which means, sorry, A or X not in B. Tamam? Okay. Now I'm going to translate. X does not belong to section 2. Means what? Exactly. Or X does not belong to B. So I got what? I got X belong to A union B. What did we do? We proved A, De Morgan's law, to the intersection is true. By what? By definition. Understood? Dears? Yes, Kak. الكترون بس بله اسا بونم الامتحان شيء اوه هنمو الله ما ببسل منه تۆ هەمان ستێپەکانی منەکەی بزە تۆ لێرە دەستپێکی بوو ئێوە دەستکەوێت تان دووسێ ڕێگەمانەیە بۆ حەلکردنەمە ئاسانترینیانەی خوێنیوانی کەم تەرە کردو ڕێگەیەکی ئلیمنتمانێت تۆزە قورساڵم تەرکن ئەواناگە ببینی ئەوان تەرکن لەوەر بە ئلیمنت کردوێتی ئلیمنت تۆزە ئیزاز بەڵام من لێرە پێێتە ئەمە چیلێکی بە پرۆپەرتی حەلێتی ئەگە دیقەت بەی هەمووی پرۆپەرتی بەکارهێناوە هیچم نەوتوە ئەمە لە دیفینیشنەکەەوە دەستم پێکردوانە تۆ بە دیفینیشنی کۆمپلیمنت بزانی ئەو دیفینیشنی کۆمپلیمنت باش ئەمان چی ئەمە دەرکردنی یەک نەگەیشنە بەس بۆی ئەمە نەهێڵم ئەمە نەگەیشتنێکمان دەرکرد دوای چی ئەمە کردنەوەی پێناسی ئینتەرسێکشنە ئەندرسوت نێکست ئەم پێناسەکەی حەزەکە بڕستی دوو لاپەڕ لەمە پێش خوێنمان ئۆر و ئاندمان لەمە ئۆر ئەوە ئەگەر ئاند بوو ئەمە ئاند ئەوە هەردووکیان کاتەوە بە ئۆر و ئاند ئێستا اینجا چیەکەم ئێستا توانی بڵی دیمۆرگان بەکارێنم نەگەیشتنەکە ئەکەمەوەڵم بۆیە کەمیان نەگەیشن ئان دەبێ بە ئۆر بۆ دومیان نەگەیشن تەمام اینجا ئەمان هیچم نەکرێت و خۆی دووسیمەوە ئەم ستێپە تۆم لەمە زیایە واز لێبن دوای چیم کرد دوایی پێناسی چیم دووبارە بەکارهێنایە لێرە دووبارە دیفینیشنی ئەی کۆمپلیمنتەکە من هەنووسم کۆمپلیمنت بۆی تێبگەی نانووسم ئەی نووسم کۆمپلیمنت ئەوە بۆ وتمانەگە ئەکس لە ئەی نەبێت لە کۆمپلیمنتەکەیەتی ئۆڕەکە هەر ئۆڕ ئەکس لە بی نەبێت لە بی کۆمپلیمنتە تەمام دوای چیم کرد هەمدیس ئەم دوانم لێگایەوە ئەڵە ئەمە معنای ئۆڕەگەین ئەمە دیفینیشنی یونیەنەگە دیقەت بێ یان یەک شتم نەکردەوە پێشتر نەخوێندو هەمووشی ئاسانە چوارت دێڕە تۆ هەوڵ بە try to solve داتۆ ئێستا چیمان سەلمان ئەوەمان سەلمان پروفمان کرد بەچی بە دیفینیشن دەنابێت ئەمە وەکو هاومۆرگ بەکاربێن کلیر تەواو ئەبێ دەست پێ بکەی لەم لاوە دیفینیشنی ئەم جارە کۆمپلیمنت و یونیەن دوای ئاندی لێ دەرکەی گوت بەسە هەر ئەمە بە PDF شانیەم و ئەوەتە دوای بۆتان نێرم عکسی ئەوەی پێشوە ئەی یونیەن بی ئۆڵ کۆمپلیمنت یعنی دیمۆرگان بەشی دووەمی دوو پارچەی دیمۆرگان yes دیقەت یێرە بە ها ئەمە چی کردووە ئەگەر سێ سۆلیشتەکان کە بەس بووم جارێ بە پێی دیمۆرگان ئەم ستێپاکەم وایە ئەمە بێتە ئەی کۆمپلیمنت ئینتەرسێکشن ئەمە هەر هەمووی کۆمپلیمنت ئەمە ڕایت تاخۆڵە چی بسەلمێنە ئەمە بسەلمێنە that one equal to that one ئەمە زۆر ئەم پرسیانە زۆر جوان بۆ ئێگزام important بۆ چکە ئەلم پرسیارانەیەنەوە وردن تەنها ئەرزام تەلەوەکان خۆنیان بڵم define the intersection and union no ئەوت بووە نوزام تێگەیشتووی لە کۆمپلیمنت و لە یونیەن و لە ئینتەرسێکشن و دیمۆرگان هەمی بەکارێ لێرە وایە easy but details دیتێڵیەوێ ستێپ بکەن ئاگادار بن کاتە من دێم چی یەکەم ئەمە بیسەلمێنم A union B all complement equal بە C union B intersection A ئەو شتی کە نووسراوە لەپەنە ئۆکێ تۆ هیچ ینی ڕێکە لە خۆت یەک نایی دایمە باشترە لەم لاوە دەست پێ بکەم کاتە من ئەزانم if I have that one we have that one how we deal with it part by part okay so A complement intersection all these complement A complement intersection all these complement okay again complement is doing what De Morgan again make that one B complement union C complement am I right now شتێک ماخوێن we talk about distribution we say distribution you can use it you cannot use it here you got the formula just you need commutative so I say this part I can change the sweep it with that part am I right tamam A we say union or let me say we say in general X intersection Y equal to Y intersection X am I right so my X here is A my Y here is what B union C complement so there's no difference I'm going to sweep them so we got what we got BUC am I right intersection A complement we sweep it my X is changed to that one good now we have what? We sweep it, we got that one. Again, here I'm going to sweep because A union B equal to B. Let's see. Easy. It's not hard, but actually you need to combine to solve together. Okay, dears? Any question? Any question? Any point? Okay. So we have generalization of union and intersection. And we have for finite set and infinite set. Now, of course, for union, And be sure one of question will be here and the other question will be here. So kindly pay attention. 100% there's a question during this page. How? Now, of course, my questions will be 15 because easy. If we have 3 sets, we can find what's the common between them. 0, right? 0, 0. 2, 2, no 2. 4, 4. So I have only what? Only 0. Am I right? You just check. It's easy. That example is just to understand. But what's the important? If I have for finite set, and look, Venn diagram, here's the intersection, here's the union. Now we have a collection like that. This is important. Definition 6 and after the definition of 6 definition. We have the union of n terms. For example, I have A1 equal to 1 and 2, A2 equal to 1 and 3, A3 equal to 1, 5, 6, and go on. So how we union between 10 or 100 sets together? That's the question. Look at here. And of course, again, for intersection, we are going to write that one. This one is called infinite many or infinite intersection or infinite union. Sorry, finite. Why is it finite? Because we have n. N means that stop at number. Maybe with you 10, maybe with you 11 or 5. Good. So now tell me about the union of the set. That's why I say this is important. Tell me about the set AI. So give me union of AI when I tends to n. That's the question. Yalla. They equal to what? What do you mean by positive infinite? What do you mean? I like what? Set. Give me the set. Set is equal to what? Okay. I'm going to start with the first set. Okay. I'm going to expand the first term. Yalla. Give me A1. A1 is equal to what? A1. 1? No. 1, 2, 3, 4, and go. Why? Because he say when you input anything, you have that one, plus that one, plus that one, and go on. So I'll get what? 1, 2, 3, 4. Am I right? Okay. Did you understand? They give me the second set. Actually, it's like it's very important for your programming. You have a set like that. I know. You have I plus 1. Yalla, give me the A2. A2. Should start with a 2, 3, 4, and go. How about A5? 5, 6, 7, and go on. So tell me about the union. Can you imagine? Let me say A3 equal to 3, 4, 5, and go on. So give me the union till n. Till n, maybe 100, 200, I don't know. Give me the formula. I say union of all AI, I from 1 to n, for this set, for not all, this set, yalla. No. Is equal to what if we took a union? I told you, if you have a union between the large, small, you will get what? Largest. So which one is the largest of the sets? A1. Every time A1 is greater than all of them, because if you start with the I1, you'll get 1, 2, 3. 2, you'll get with a 2. 3 with a 3. So which one is the largest one? A1. Am I right? The result will be A1. So it means that the result is 1, 2, 3, and go. You got it, dear? Hello? You get it? Really? Yalla. Give me the intersection. If you get it, you should answer. Because you have a set, A1, A2, yalla, give me the intersection. Yalla, think. Wallah, is very nice. Yalla. From 2? Why from 2? In the third step, we don't have a 2. How do you know the intersection is 2? It's the last set. What was the last set? No. AM, thank you. So intersection, how you can imagine the intersection between I2 and 2, AI equal to AN. Tell me about AN is like what? N plus 1, N plus 2. Am I right? And go. You got it? So here's the union, here's the intersection. Easy, but you need to play with your idea, play with the things that you have. Clear, dears? Good. Now, this is very important, this example. And we have another important example. Now, how about for infinite intersection, infinite union? How about that one? In the previous one, we got a finite, right? Kaka? We got a finite. How about now? Infinite. Yalla. Here's the example. Again. But look at the example. Careful. It's not like a previous one. Careful. We have a A1 equal to, AI, sorry, equal to now, we see that AI equal to 1, 2, 3 till I. So tell me about A1. So before you are doing union or intersection, find the sets, at least 5 of them, 3 of them, to get the I, to know you are dealing with what. Yalla kaka. Only 1. You are right. How about A2? 1, 2. A3, yes, 1, 2, 3, and go on. We don't say AN because we don't have an AN. We have an infinite. Okay. So tell me about the union of AI when I tends to infinity from 1. Yalla. How many we have? Infinity. Is equal to what? Z positive, exactly. We have 1, 2, 3, and it's not stopping. We don't know. There's no stopping, right? So we will get Z positive. Why she didn't say natural number? Natural number. Zeros is included. You are right. 0. If we say natural, it should be zeros here, but we don't have a 0. Okay. Tell me about the intersection of infinite set. Yalla. It's A1. You are right. Only 1. A1. Because 1 is repeated, all of them. You cannot say 1 and 2. Why? Because at the first, we don't have a 2. That's it. Easy, right? Look like hard, but when you deal with it, it's easy. Any question, dears, about the general union infinite? Tamam? So here we are. And here's the set. Okay. It's easy. Yalla. Before the rest, let me finish that on computer representation of sets. When we have a set, universal set, and I say find the representative element. For example, to understand computer representing numbers, I say what? I say let U be 1, 2 till 10. Okay, U1 or UO, let me the odd. 1, 3, 5, 7, 9. Am I right? And UE be the even. So we have what? We have what? What's going on? 2, 4, 6, 8, 10. Good. Or maybe you have another set, A star or anything, AC. We have 1, 2, 3, 4, 5. Now, we say if you want to represent, generally, if I want to represent U, I'm going to write like a digits. I say I have 10 digits. Okay, all of them are 1, 1, 1, 1, 1. This is U. If I want to represent U odd, just odd, I'm going to change it, that one, to 0, 0, 0. Now you understand, right? How about even? If I want to talk about even, I'm going to change, yeah, not even, just U even. I'm going to erase the odd. Now, with the universal, all of them on. So I'm going to talk about UE. So I'm going to change to the 0, right? 0, 0, 0. Sorry. Understood? So that's why we have a 0 and 1 here. You can check it here. Now, if you see that one and you have universal, you know that one is odd, means that 1 and 9. That one is 2, 4, 6, 8, 10. How about that one? Can you translate that one for me? What do you mean by these numbers? Yalla kaka. Yes. We have 1, 2, 3, 4, 5 are exist and the rest are zeros. So my set is what? 1, 2, 3, 4, 5. Because the other are rest or off. How about complement? The same. Tell me about the complement of here. 0 will change to the 0, 1 to 0, 0 to 1. Clear? Easy? How about union between them? How about union or between them? Of course, 1, 1 or 1. 1, 0, 1. And go on. 0, 0, 0. Am I right? It's like an or that we have before. How about and? Of course, 1 and 1 and. 1 and 0, of course, 0. You got it, dears? Any question? So forget about multiple sets. We forget about the example of course 21 first. And you have this section as a, what do you say? Any question about 2.2?